Welcome back, everybody. We're talking about electric force practice problems. And away we go, right? We're talking about charges. So number one says, how do like charges behave, like two negative charges? And then how do two opposite charges behave, like a positive and a negative? Right? So we're really looking at and saying, well, if I have two negative charges right here, like say two electrons, these two charges are going to repel away from each other, right? Like charges repel. Similarly, if they were both positive. So, all right, if I take a positive charge and a negative charge here, and I try to push those together, what those are going to do is those will attract, right? Because opposite charges attract. That's a Paula Abdul song from the 80s, folks. All right, number two. The goal of physics is to fully unify all of the fundamental forces into one to create what we call unification or a grand unified theory. So why is it proving difficult to unify the forces of gravity and electricity even though their equations look similar? So here we have the mathematical relationships for the force of gravity and for the electric force. Yes, and at first glance they look to be very similar, right? The law of gravitation is a force between two masses separated by a distance. There's a constant of proportionality there, big G. Coulomb's law, similarly, it's a force between two charges that are separated by a distance, and also a constant there too. So you'd think, well, hey, if the equations look that similar, that maybe there's some relationship between the electric force and the force of gravity. Maybe they're somehow related. But you would be wrong, because the electric force is so much greater than the force of gravity. It's billions upon billions of times stronger. And that difference in strength is why it's proving very difficult to unify the electric force and the force of gravity. Okay, let's take a better look at Coulomb's law here. And try some problems here out. So we want to use Coulomb's law as a guide to our thinking and make some changes here, right? So if the charge on one of the particles is doubled, what happens to the electric force? So if I have these charges Q1 and Q2, and I double Q1, what's going to happen, right? All right, so if I make Q1 twice the amount, well, that means I have an extra 2 here, so the new electric force will also double in the amount, okay? And that's because electric force depends directly on charge. So whatever the charges do, the electric force does. For B, it says if instead the charge on both particles is doubled, what happens to the electric force? So here I'm going to double both, so 2Q1 and double Q2 as well. Well, 2 times 2 is going to give us 4, and our new electric force will be 4 times the amount. Again, because electric force depends directly on the amount of charges. So that would be quadrupled. Okay, all right, let's try some more here, everybody. 3C, right, and 3D, I guess. So it says if instead the distance between the charges is halved, cut in half, what happens to the electric force? So now we want to take and make this not d squared, but 1/2 d, right? Half the distance. So we're going to have to do a little bit of math here. Otherwise, what's 1/2 d times 1/2 d? Well, if I do that math out, 1/2 times 1/2 is 1/4, and d times d is d squared. So I have 1/4 d squared on the bottom. So keep in mind, if I make the distance closer, the electric force is going to go up, because if I decrease this distance, the electric force will increase. It'll do the opposite, because electric force is inversely related to distance. Okay, so if I decrease the distance, the electric force will do the opposite and increase. How much will it increase? Well, here it looks like it's going to increase by a factor of 4. Ooh, I want to keep that in red. By a factor of 4, right? Because really I have 1 over 1/4 here, which is really 1 times the inverse of that, or 4 over 1. So I get an increase of force of 4. Okay? All right, for D, it says if I have the distance and then I double both charges, how much will my electric force change? All right, so we're doing a lot. We're changing charges and force. So I'm going to double both charges and make this half as much distance. Okay. Hey, if we remember from some of these other ones, when I have the distance before, that means I'm going to make the electric force go up by 4 times, right? Because 1/2 d squared is 1/4 d squared, right? And again, that's inverse. So this is going to be 1/1/4, which is really a 4. So we're going to have an extra 4 up here from that, times 2 times 2. So that looks like 4 times 2 is 8, 8 times 2 is 16. So the new electric force will be 16 times the amount as it was before, okay? All right, number 4 is actually putting some numbers in and actually getting some numbers. So we've got, what, 3 of those to do? All right, let's get all that on the same screen. All right, so it says 2 charges separated by a distance, so the electric force is 10 newtons. Determine the new electric force in the following situations, okay? So I triple one charge. Got it. So I'm just going to make one of these charges, maybe this one, triple the amount. So that'll make the new electric force 3 times the amount also, since they're directly proportional. So if the original force is 10, 3 times 10 is going to be 30 newtons as my new electric force. All right. I want to double one charge now and triple the other. So this is doubled, this is tripled. So it looks like my electric force will now be 6 times the amount, more charge, more force. And the original force, again, was 10. So 6 times 10 is going to give me a new force of 60 newtons. Got it. All right, for C, it says the distance between the charges is doubled. Okay, so I'm going to make this 2d squared, right? I'm going to leave the charges the same. So 2d squared, so if I do that math out, that's going to give me 1 over 2d squared, that's 4d squared, all right? So that means my force is going to be 1/4 as much. So if the electric force before was 10, it's 1/4 of 10, or I think that is 2.5 newtons of force, okay? Let's take a minute and look at B and C again. So it says when I double one charge and triple another charge, double and triple, the force goes up by 6, right? Because the force is directly proportional to charge, so it'll increase the same way the charges do. Here, if I increase the distance, so if I double the distance, the force between those charges does not double because the force depends inversely on the distance. So if I increase the distance here, the electric force is going to decrease and do the opposite because it's an inverse relationship between force and distance, okay? And force and distance squared. So I have to do 2 squared and get 4, and that new force will be 1/4 as much. Thanks, everybody.